Here's a scenario you probably know all too well if you work in CTI. You get an alert, a suspicious IP. You pivot to VirusTotal, tab 1. Then AbuseIPDB, tab 2. Then GreyNoise to figure out if it's just a scanner, tab 3. Then you check your MISP instance to see if any of your sharing communities have seen it before, tab 4. Then you pull the Feodo tracker feed to check for botnet C2 overlap, tab 5. By the time you've finished that pivot chain, 15 minutes have passed, and that's for one indicator. Multiply that across a shift, multiply that across an investigation with potentially hundreds of IOCs. That is the context gap, and it's the number one reason CTI analysts burn out and investigations stall. What if you had an AI assistant who could do that in seconds? Not by guessing, not by hallucinating threat data, but by actually connecting to those platforms in real time, pulling live intelligence and putting it all together to create a coherent picture, while you focus on the analysis that actually requires a human brain. That is exactly what Model Context Protocol servers make possible. After this video, you'll understand what MCP servers are, which ones are useful for threat intelligence work right now, and why the same architecture that makes your AI faster also creates a new attack surface you need to defend against. Let's get into it. Before we touch on a single threat intel tool, we need to understand the underlying architecture. The Model Context Protocol, or MCP, is an open standard developed by Anthropic. Its job is simple. It creates a universal interface between AI language models and the external data sources or tools they need to work with. Before MCP, connecting an AI assistant to a new data source required a custom integration every single time. Want your AI to query VirusTotal? Well, you need to build a connector. Want it to also hit up AbuseIPDB? Well, you need to build a completely new one. Each connection was bespoke, brittle, and required engineering time. It's like needing a different charger for every device you own. MCP is the USB-C of AI tooling. One standard, any model, any data source that implements that spec. The architecture has 3 tiers. At the top, you have the host. This is your AI application. Think Claude Desktop, a custom SOC chatbot, or a notebook environment. Inside the host, an MCP client manages each individual connection. And on the other end, you have MCP servers. These are the programs that expose the actual tools, data sources, and templates your AI can use. Within those MCP servers, there are 3 types of capabilities. These are called primitives. You have tools, which are executable functions. When your AI runs a VirusTotal hash lookup, it's calling a tool. Then you have resources, which are read-only data, like pulling the last 90 days of authentication logs for context. And finally, you have prompts, which are pre-built templates for complex, repeatable tasks, like a guided phishing header analysis workflow. For us as CTI analysts, the practical implication is this. Instead of manually pivoting between 6 platforms, you describe your investigation to an AI assistant, and it calls the relevant MCP tools in sequence, synthesizes the responses, and gives you a coherent intelligence picture. That's the gap that MCP closes. Now let me show you the tools that are already doing this. The MCP server ecosystem has grown fast, and there are several implementations purpose-built for threat intelligence. I'm going to walk you through the 4 most relevant ones right now. The first is a TypeScript server called MCP-ThreatIntel. What makes this one valuable is that it turns the 5-tab pivot chain I described at the start of this video into a single prompt. It aggregates AlienVault OTX, AbuseIPDB, GreyNoise, URL-Hars, MalwareBazaar, ThreatFox, and the Feodo tracker under one server. You submit an indicator once. The AI orchestrates the enrichment across all of them simultaneously and gives you a synthesized picture. Setup is straightforward. Install it via npm, configure your API keys as environment variables, and point your AI client at the server. I'll put the GitHub link in the description. The second server is FastMCP-ThreatIntel. It's built in Python using the FastMCP framework, designed for enterprise environments running complex, multi-step queries. Here's what changes with this tool. You feed it a set of indicators and TTPs from an investigation, and instead of getting a flat list of results back to you, you get a confidence scored attribution assessment mapped to MITRE ATT&CK with an interactive infrastructure graph rendered in D3.js, showing how the indicators relate to one another. It even lets you export this in STIX 2.1 format, so everything it produces can be ingested directly into your threat intelligence platform or SOAR platform without reformatting. The AI isn't just answering, "Is this IP malicious?" It's answering, "This indicator pattern with this confidence score is consistent with the TTPs of this threat group." That is actual intelligence production, not just another indicator lookup. For CTI analysts who need to produce deliverables like threat reports, briefings, or intelligence packages, this changes the workflow from gather data, then spend hours reformatting it, to review and refine what the AI has already structured for you. 2 more worth knowing. The VirusTotal MCP server exposes the platform's relationship APIs. An AI agent can start with a single IP address and autonomously chain relationship queries, communicating files, historical SSL certificates, passive DNS records, related domains, until it's reconstructed an entire campaign infrastructure map. One starting indicator becomes a full picture of an adversary's operational footprint. And then you have the MISP MCP server. This bridges your AI to private threat sharing communities. It gives access to MISP galaxies for actor mappings and sightings for real-world observations. For anyone in an ISAC or information sharing environment, this is the connector that bridges your private intelligence into the AI's context window. It is the difference between saying this IP appeared in a VirusTotal scan and this IP was cited 3 times in the last 48 hours within the financial sector. That context is what separates intelligence from raw data that you need to do more with. Quick question for the comments. If you're working in CTI or SOC right now, are you already using any AI tools in your investigation workflow? Or is this still on the to evaluate list? Drop your answer below. I'm curious where people are with this. Those community tools are powerful for individual analysts, but what happens when you plug MCP into the data lake sitting inside a Cortex XDR or a Microsoft Sentinel. That's where the operational impact steps up to a different level, because now your AI isn't just querying external intel feeds, it's querying your organization's own telemetry. Here's where I need to slow down a little, because this is the part that most MCP for security content will gloss over, and it is the part you need to understand the most, both to defend your organization and because these are the attack vectors you'll be writing intelligence reports about in the coming months. The same architecture that makes MCP powerful for defenders also creates a new attack surface. When an AI agent has access to internal databases, can execute queries, and can communicate with external services, that becomes the target for threat actors. Let me give you a couple of examples from early 2026. Threat actors cloned a legitimate MCP server, one built to connect AI assistants to the Aura Ring health data, and poisoned legitimate MCP registries with a Trojanized version. They built a network of fake GitHub contributors to manufacture credibility. The lesson here isn't don't trust GitHub. The lesson is that MCP servers have privileged access to your internal data and your AI's execution capabilities. Your vetting process needs to match the privilege level. 100 stars and active commits is not a security audit. If you wouldn't install an unvetted browser extension with admin access on an analyst workstation, you shouldn't install an unvetted MCP server with access to your SIM data. Next up, we have the Rogue Pilot, which was a passive prompt injection in GitHub codespaces, hiding malicious instructions in a GitHub issue description using HTML comment tags, invisible to a human reading the issue. When a developer opens a codespace from that repository, GitHub Copilot automatically processes the hidden instructions as an initial prompt. The exploit then tricks Copilot into checking out a crafted pull request containing symbolic links to internal files, reads those files, and exfiltrates data. No warnings. The entire attack happens inside a trusted developer workflow, using the AI's own authorized capabilities. Then we have AI in the middle, turning AI services into C2 proxies. Researchers have demonstrated how to turn legitimate web-based AI services into command and control proxies. Because services like AI assistants and coding tools are trusted, their traffic passes through corporate firewalls without much scrutiny. Attackers can tunnel malicious commands through them as though they are a legitimate business tool. Traditional domain blocking doesn't help because these are domains your organization actively uses. That's the threat landscape your AI tooling is operating in. Okay, you understand the capability, you understand the risk surface. Now let's talk about how to actually do this responsibly. Because the answer is not don't use MCP. The answer is use it with the right security architecture in place. The fundamental shift required is moving from traditional API security thinking to an identity-first, zero-trust model, where every agent, every server, and every tool is treated as a distinct non-human identity with explicitly defined permissions. Let me walk you through the core controls. Control 1 is authentication and authorization. Every MCP server connection should be validated against your corporate identity provider using OAuth 2.0 or OIDC, short-lived scope tokens per tool. not long-lived API keys sitting in a random environment variable file. This is your first line of defense against token theft and session hijacking. And authorization needs to be granular. Not this agent can use the MCP server, but this agent can call these specific tools on these specific resources and nothing else. Policy as code frameworks, like Open Policy Agent, are how you enforce that at scale. Control 2 is least privilege at the tool level. Your threat intelligence MCP server doesn't need write access to anything. Define explicit allow lists for what each tool is permitted to do. If a tool doesn't need network egress, it shouldn't have it. An agent doing IP lookups should not also have write access to your MISP instance. Control 3 is isolation. Run MCP servers in containers. High sensitivity deployments should consider trusted execution environments. The goal is that if a server is compromised, the blast radius is contained. It cannot pivot into your host environment. Control 4 is supply chain integrity. Enforce mandatory code signing verification for every MCP server you deploy. Treat MCP servers the way you'd treat any third-party code running with privileged access, because that is exactly what they are. Use private registries with security scanning. Don't install from public npm or pip repositories without vetting the source, reviewing the code, and verifying the maintainer's identity. And finally, we have Control 5, observability. Make sure you log every tool invocation, hash the inputs and outputs, timestamps on everything, feed those logs into your SIM, and set up UEBA rules for anomalous tool call patterns. An agent calling curl to an unfamiliar external IP address at 3 in the morning is a detection opportunity, but only if you're logging the tool calls in the first place. Where is this all heading? Let me close with what I think the next 2 to 3 years look like for CTI analysts, because this matters for how you position yourself professionally. The current MCP ecosystem is what I describe as an agentic adolescence. The power is real. The security controls are inconsistently implemented. The standards are still solidifying. That pattern should be familiar to anyone who has lived through the early cloud migration years, or the first wave of DevOps adoption. The capability arrives first. The governance catches up later. Usually after the first serious incidents force the issue. 3 things that are happening in parallel will shape this space. First, secure by default configurations. The current situation, where authentication and encryption are optional in many MCP implementations, is not sustainable for production environments. The industry is moving toward mandatory TLS, short-lived scope tokens as baseline, and potentially native cryptographic workload identities baked into the protocol itself. Future protocol versions will likely have permissions models built in rather than bolted on. Second, the MCP gateway pattern. As organizations deploy more MCP servers, the MCP sprawl problem becomes real. AI agents connecting to dozens of servers without central visibility or policy enforcement. The gateway is the answer. A centralized control point that sits in front of all your MCP connections, providing observability, access control, and threat prevention across your entire AI tooling estate. Third, and this is one important for your career, the analyst role is bifurcating. The baseline investigation work, IOC enrichment, correlation, first pass triage is going to be done by AI agents operating through MCP connected tool chains. That's not a threat to the CTI analyst role. It's just a redistribution of where analysts' time will go. The time saved on mechanical enrichment tasks shifts toward the work that AI cannot do: geopolitical analysis, adversary intent assessment, stakeholder communication, and strategic intelligence production. The analysts who thrive in this environment will be the ones who understand how to build, configure, and govern these agentic workflows, not just consume them. The transition from AI assistant that helps me write my threat reports to AI agent that actively participates in investigations is already underway. MCP is the infrastructure layer that makes that possible. The question is whether you're going to be the analyst who shapes how your organization adopts these tools, or the one who's handed a tool someone else configured. You decide. Hit subscribe if you want to stay current on where CTI tooling is heading next, and I'll see you in the next one.